So yesterday we did putting points on a coordinate plane and then looking at points on the coordinate plane and giving the coordinates. So today we're going to be reflecting points across the coordinate plane. So a reflection is when you take a point or an entire object that's on the coordinate plane and you flip it over the origin, which is 0, 0, or the x or the y axis. The point of object looks like it was literally picked up and dropped on the other side of the axis. So it's the same distance across, same shape and everything, just flipped over. So important things to notice: if you flip something over the x-axis, which is the horizontal one, that means that the x-coordinates are going to stay exactly the same and the y-coordinate becomes its opposite. So if the y-coordinate was like a -2, it would become a +2. If the y-coordinate was a +4, it would become a -4. But the x-coordinate, which tells you how far right or left, would stay exactly the same. When flipping something over the origin, so the center here, both coordinates just become their opposite. So if they're positive, make them negative. If they're negative, make them positive. So let me show you. It's best to just get right into an example. So let's say that we have the point 3, 4. So I'm starting at the origin. I'm going over 3. I'm going up 4. And I'm going to put a dot. So let's call this point A. You guys can do this one with me. So I went over 3, went up 4. So that's in quadrant 1. That's my point. Let's say I want to reflect it over the y-axis. So we know that this is the y-axis, the vertical one. If you're going to flip it over the y-axis, it literally means you're picking it up and throwing it on the other side. So when you're flipping it over the y, that means the y stays the same. So the y is the second number. And the x becomes its opposite. The opposite of 3 is -3. So let's go and graph that point. We're going to go to the 3 to the left and up 4. So that's our reflected point. We've literally picked it up and threw it over the y-axis. That's basically what you're doing. So we still have to be 3 spots away, but instead of 3 spots away to the right, we're 3 spots away to the left, and that's why your x-axis becomes the opposite. It's still 4 spaces high, which is why the y stays the same. So that's flipping over the y-axis. All right, let's try another one. Let's say we have, let's go to -2, +2. So I'm going to go 2 to the left, up 2. So I'm quadrant 2. We'll call this point B. So this is -2, +2. Now, let's pretend we want to reflect it over the x-axis. So the x-axis is your horizontal line. So we're picking up B and we're throwing it over that line. So where's it going to end up? Quadrant 3. So since we're flipping it over the x-axis, the x point coordinate stays the same. So x was -2. It's going to stay -2. And y becomes the opposite. Opposite of +2 is -2. So let's graph this point. 2 to the left, 2 down. So we flipped it over the x-axis, which means we pretty much picked it up, threw it over the x-axis, and here it is. So when you're flipping it over the x-axis, the x-coordinate stays the same, the y becomes the opposite. When you're flipping it over the y-axis, the y-coordinate stays the same, and the x becomes the opposite. So I'm going to give you a couple of these to try.